If you line up a large group of people by height, most of them won't be extremely tall or extremely short. Most will cluster somewhere in the middle, with fewer people as you move away from that center. When you plot those heights, that pattern usually forms a smooth, symmetric bell shape. That shape is called a normal distribution. Saying that human height is approximately normally distributed means we can summarize an entire population using just two numbers. The first is the mean, which is the average height and also the center and peak of the curve. The second is the standard deviation, which tells you how spread out people's heights are around that average. A small standard deviation means most people are very similar in height. A larger one means there's more variation. The normal distribution also lets us turn that curve into clear statements about real people. Roughly 68% of people fall within one standard deviation of the mean. About 95% fall within two standard deviations, and almost everyone falls within three. So if the average height of a group of adult men is about 178 centimeters, with a standard deviation of around 8 centimeters, then most men are between about 170 and 186 centimeters tall. Another powerful idea is the z-score. A z-score tells you how many standard deviations above or below average a person is. A z-score of 0 means average. A z-score of 2 means quite tall relative to that group. This lets us talk about percentiles and probabilities, like how rare it is to be taller than 190 centimeters. Heights tend to follow this pattern because they're influenced by many small factors at once: thousands of genes, nutrition, health, and environment. When lots of small effects add together, the result often looks like a bell curve. But the normal distribution is a model, not a law of nature. It works best when you define the population carefully. Mixing men and women or children and adults can break the pattern, and the very tallest and shortest people often appear more frequently than a perfect normal curve would predict. So what does a normal distribution tell us about human heights? It tells us what's typical, how much people vary, how rare extremes are, and how to compare individuals and populations in a precise, meaningful way.